Good morning. Sunday, 13th of December, and we're still in the game. Have not decided to bail yet, because so far we're still able to do these puzzles in a reasonable amount of time. They are getting a little harder, so again, I'm not going to spend too much time on rehashing stuff. We're just going to dive straight in and see if we can get to a solution for part one, which seems pretty doable for today, and then yeah, we'll get on with part two. If you're watching on the live stream, do come say hi in the chat. Makes a real difference for me to know that I'm not just here sort of talking to myself. Yeah, let's see what we have. So we're still on our way to our tropical destination, blah blah blah, and we made it to a seaport where we need to take a bus to the airport. And so the input looks like this, where the first number is basically the current timestamp. Okay, input looks like this, haha. Where the first number is the current timestamp, just an incremental number. And then we have a bus schedule. So these are bus numbers. The axis we can ignore, might come into play on part two, we'll see about that. The other numbers are bus IDs, but they're both the ID number of the bus, but really they are the time that it takes a bus to do a loop from the seaport to the airport and back. And they all start at time 0 for their first loop. So you can see here, so this is bus 7. So every 7 minutes, at 9:31, at 9:38, it arrives at the seaport or departs from the seaport. Whereas this one, it's only every 13 minutes. This one's only every 59 minutes. We need to find then basically what's the next bus that we can take. So in this case, we are, we get to the seaport at minute 9:31. So the next bus we can take is at 9:44, bus 59. That means we have to wait 5 minutes. Multiplying 5 by 59 by the bus number is 295. So let's see. I think that's pretty doable. There you go. Let's make that a little bigger again. Day 13. Got a REPL connected, so we are good to go. Demo input. That's this. And I'm just gonna throw an RE-seq over that. So, and yeah, we can ignore the axis for now. So really, we just care about D plus, sequence of digits. All right. And yeah, let's immediately require our util namespace. Couple people on the stream. Do say hi in the chat, folks. I know it's early and you just want to lurk, but it makes a world of difference. So that means that we can map over this util parselong. Good, got our input. Demo parsed. Now, yeah, so first of all, we need to split this into timestamp and buses. And then basically, if you look at Darren Leo is working on part 2 already. We're not there yet. Yeah, so here, so let's say, so we're at 9:39. Here's bus 7, which passed by 1 minute ago and will be there in 6 minutes. So what I figured is that if we just get the modulo of 9:39.7, for instance, that's 1. Why is that 1? Because it passed 1 minute ago. So 9:38 is divisible by 7, and then we're 1 minute after that, which means that the next time bus 7 is going to come is 7 minus 1, right? Is 6. So if we say for buses, this is the bus ID, this is the timestamp, this is the bus ID, then we get this 6, 10, 5, 22, 11. So the third one is bus 59 is indeed the next one, and that's 5 minutes away. So that's good, but let's also keep track of the bus ID. And then we say sort by second. What does that look like? 59.5. So then, if we just get the first of that, and then the second of that, we get 5. No, actually, we need both. We need the bus ID multiplied by the numbers. So we just need to say apply, multiply. 295, 295. Indeed. So yeah, I think that's already good enough. CLJ projects, AOC, and then we're gonna fetch input for day 13. Real parse. Let's just copy that. But do we have got these really specific let's just do this and then replace these. Total input day. It's like every day we're parsing it in a slightly different way. But so yeah, so let's say util puzzle input 13, and then we just slurp that and parse that. What does that look like? Oh, that's it? I guess that's it. Okay, yeah, we're definitely, these X's are gonna come into play on the second part, but we'll see about that. Yeah, so real parsed 2238. 2238. Yeah. All right. 10 minutes in. That's not bad. But part 2. The shuttle company is running a contest. 1 gold coin for anyone that can find the earliest timestamp such that the first bus ID departs at that time and each subsequent listed bus ID departs at the subsequent minute. The first line in your input is no longer relevant. Okay, we can ignore that. Suppose you have the same list of bus IDs as above. An X in the schedule means there are no constraints on what bus IDs must depart at that time. This means you are looking for the earliest timestamp, called T, such that bus ID 7 departs at timestamp T. Bus ID 13 departs 1 minute after timestamp T. Ah, yeah, okay, yeah. So these are subsequent, yeah. There are no requirements or restrictions on departure at 2 or 3 minutes after timestamp T. So each position, the index of each number determines how many minutes after the first one it should start. The only bus departures that matter are the listed bus IDs at their specific offsets from T. Those bus IDs can depart at other times, and other bus IDs depart 7 minutes. Yeah, so the only bus departures that matter are the listed bus IDs at their specific offsets from T. Those bus IDs can depart at other times, and other bus IDs can depart at those times. For example, in the list above, because bus ID 19 must depart 7 minutes after the timestamp at which bus ID departs, bus ID 7 will always also be departing with bus ID 19 at 7 minutes after timestamp. These descriptions are so confusing. I feel like they go out of their way to make it unclear. But yeah, I mean, we need to find, so in this case, there's an X in between here. Now there's two X's in between here, which is what you see here, that there's two gaps in between. I mean, I think that's clear. It's kind of a constraint solver, right? Now, okay, so so it's kind of like, can we do this with, I'm kind of tempted to pull in core logic, but I don't use core logic that often, so you might have to poke at the API a bit. I'm also not sure if core logic is really gonna be much faster. Let's start by encoding at least what we have. Okay, so in this case we're gonna have to parse this slightly different. So now we want to get either a digit or X. Actually, what happens if we do util par? Actually, I just, instead of parse long, let me just use read string on this. Right. And we can ignore the first number, so let's already chop that off. Yes. And I want to turn that into, let's see, if we do a map indexed, actually can keep, take multiple, no, it's not like map, it only takes one. So yeah, real parse 2, and then does the index come first or second? I always forget. I think it comes first. Yes. filter some. Okay, so it's a bit more compact index bus number, or offset, expected offset bus number. Okay, how about we do something like this? So let's say, you know, let's take the first one. Hey Mitesh, welcome to today's stream. So if I do a range, no, I don't want to do a range because then I need an endpoint if I want to do the step. If I just do an iterate plus 19, starting in this case from 0. Let's take 10 of those. So this is the first bus, right? Like the first bus has ID 19, so it comes every 19 minutes, and it starts at position 0. So these are the times when bus 19 comes. Now, I mean, they all start, if you, yeah, according to the description, they all start at position 0, but we expect them, we need them to come at a position 1 later. So let's go again. Let's take our second one. This one should arrive at position 9. So if we say, you know, if we iterate over 41, but starting at -9, we just kind of shifted 9 positions back. So what's the expected input? Well, I'm dealing with the real input now. Let's go back to the demo input. And let's wrap this in a function. Then bus cycle index bus. So plus bus minus index. And def demo parsed 2. We need here demo input. Okay, let's do this. Parse to input. Put that reseek in there. Input. Bit of an ugly function, but if we do a thread last, it's already a little better. Okay, so now we should be able to say demo parse2 is parse2 demo input, and real parse2 is parse2 slurp util puzzle input 13, right? Yes, filter sum. Map read string. And yeah, we can ignore the second one, so let's do that. Right. 7 at position 0, 13 at position 1, 59 at position 4. So 7:13, 59, yes. 59, 4 minutes, yes. So that's our demo input. Yes, and real input after properly parsing it. Oh, parse to. Yeah, okay, that looks better. Okay, now let's say we take the bus cycle for bus cycle for 019, for instance. Then we should find that this number, which is our target, is in there. So now this will be interesting, because if this is false, then this is not gonna terminate. But I think it should be truthy. So let's see if that is correct. No, that does not terminate. Are we one off or something? Let's do drop while. So we're expecting 81. We're getting, 88, 81. Oh, I'm not looking at the right. Wait, why 7? Yeah, 07. Okay, I'm just looking at the wrong one. Yeah, so that one comes at 81, and then if you look at the second demo parsed to 113, so 113 also comes at 81. Cool. So now we just need to sort of take the subset of these different cycles. How are we going to do that? Okay, first of all, if this number, what happens if I multiply this by 2? Does this kind of repeat? (63, 62). No, it does. Of course, it does not repeat. Okay, well, let's first try the kind of the naive way, I guess. Okay, I'm gonna take my demo parse 2 and sort it by second and reverse that, so that we can sort of start with the most coarse-grained one. That way we can already skip most of the numbers. And then, yeah, how do you take a subset of infinite sequences? map bus cycle. So now we have a bunch of infinite sequences, and we just need to take the first one that occurs in all of them. Okay, let seeks. So let's say, you know, current number is actually, you know, ns. I will often, if I sort of have a variable and then a sequence of the rest of those variables, I will usually just tag an s at the end. It's kind of a naming convention. First seek, so we loop over the first one. Let rest seeks. Now for each of these we do a drop while current number is smaller than our current n. So yeah, let's actually pass these in seeks, so we can recur like that. If apply equals, and we're looking at map first rest sequences, then we're done. N. Otherwise, recur cons and rest seeks, tag that one back on. So I don't know if it's kind of clear what I'm trying to do. Next seeks. Actually, let's call this to do it. Destructure this to essence seeks and an s. So just seeks then. Yeah, here s. Right. So we have our cycles for every bus, and basically we're going to loop over the first one. It's the most coarse-grained one, so that's good. That way we can already skip a lot of numbers. So this is going to be, you know, like 59 minus 4, 2 times 59 minus 4. That's going to be this n. And then we take all the rest of the buses, drop everything that has already kind of passed the moment of time that we're looking at. And then the next number for each of them, if that's all equal, then we've arrived. I don't know if that's clear or if I need to explain that better. Probably need to explain that better. And if not, we recur. Actually, let's call this let. All right. Here goes nothing. Does this terminate? It does terminate. Yeah, here we need to not just drop while, we need to map over these sequences. And then for each of them, do a drop while. $781. Oh my God, does this actually work? How about when we do this on the real input? stack. Oh, ooh. That's not cool. How is that happening? Is this a lazy seek thing? I mean, it is a lazy seek thing. In Clojure core map, I mean, I guess it's this one. Yeah, we're kind of... I wonder... Because, yeah, I think we're kind of iteratively building up these drop whiles. Is that why this is... How else can we do this? Or is it because the map... I mean, it should all get realized, right? Anyone has any ideas? So, okay, where we are, it works on our test input, but our on the real input we get a stack overflow, and it seems to be one of those pernicious lazy seek issue. So the realization of the seek is turning into calling map call seek, and that calls map again. And which map is it, right? I mean, it has to be either this one or this one. I mean, I'm guessing it's this one. Is there a different way that we can write this? Would it help if we force realization of this? I mean, it should get realized here. No, that does not help. Okay. Yeah, now, so what my approach here, yeah, now my CPUs are spinning like crazy. Let's look at that real input again. It's not that many more, right? No, it's not a huge input. But I guess we're gonna get to a pretty big number. So in this case, yeah, I'm looping by steps of 373, and then kind of checking everything else. That might be a little wasteful. So I think we can sort of yeah, so I'm sure there I mean, I guess it's a straightforward math problem in a way. Is it though? Okay, so my first idea would be, because in this case we're like I said, we're stepping in bounds of 373, and then kind of checking everything else. But we can sort of do that iteratively, like jump ahead 373, and then, I mean, basically, yeah, terminate early, right? Maybe that's the first optimization we can do. Can we do this? Yeah, so over here, how about we reduce over these sequences that are left? Starting from the current N. Does that make sense? Okay, if you have a cycle, let's say you have a cycle of 5 and a cycle of 7. Let's just take some prime numbers. Then the first number to occur in both of them is 1 multiplied by the other, right? The only thing is that now I took prime numbers. If they're not prime numbers, then right, but it's basically, I mean, it's something like that, right? If you decompose these numbers into primes, or basically, yeah, take the no, is the lowest common denominator? No, it's the highest common. What's the other one? Oh, the lowest common multiple. That's really what we're talking about. The offset makes it a little awkward. Makes it a little less straightforward. Right, because like, okay, let's go back to our 5, 7, but this time this one is offset by 1. Then it's not 35, it's 55. Why is it 55? That's a difference of 20, plus 1 of our offset is 21, is a multiple of 7, which I guess is why it's 55. Yeah, I'd have to write out. I think there's a math way to do this where we can just write out some formulas. I mean, obviously, we're looking at some really big numbers. But that shouldn't in itself be a big issue. Okay, so how did we end up at 55 here? It seems like 5 times 7 plus 3 times 7 minus 1. Can we sort of generalize that into a formula? Where's this 3 coming from, right? Let's try a different example. Let's say 3 and 5. So 24. Yeah? Yeah. No, 9. How did we end up at 9? 3 times 5 minus, so that's 15 minus 2 times 5. I feel like we're onto something, but I don't know exactly what. How does 5 and 7 yield 3? 5, 7, 1 yield 3. And 3, 5, 1 yields 2. Let's go back to our sequences and just see if we can do this in a slightly smarter way while still just walking these sequences. I feel like there has to be a way to write this that actually works. Actually, let's do this now. Let's do this in a different way. Back to the drawing board. This is our input. Yeah, and so for instance 50 37, okay, we have a cycle function that can tell us 373 what that bus looks like. Now what if we, so what's the second one? 19367. What if we say filter by, so index bus 19367 times actually I guess Minus no bus cycle. Yes, so we're filtering over the bus cycle, so these are just numbers. If we take that number minus the index of the bus we're looking at and then take modulo that bus, is that 0? Does that still yield something? That already yields some pretty high numbers. Let's go back to our example that we were trying out with. So if we have 0 and 5 and then 1 and 7, no. So plus maybe, should get 55. 20? Ah yes, 20 is in there as well. Okay, so that's cool because now we can say narrow cycle. So we have our bus cycle index bus. So now we can, so we take the if we take the first of this one is 5373 and the second one let's first, right? And so that means that we can take the bus cycle of 5373 and narrow it to 19367 and narrow it to the next one again. So basically it's a reduce. Starting from and then okay, so let's say, okay, let's do this. Let S and SS, whatever, this is our input. Starting from the first one, we reduce over narrow cycle, and then we just need the first of that. Nah, still not smart enough. Let's first validate that this actually works on our test input. 781, yes, so that is correct. Is it faster or slower than what we had before? 2 milliseconds, yes, too much. Oh, this one overflows now on the demo input. Wasn't that working before? Did we change it? Okay, this stack overflows. While we're at it, let's at least start with the obvious stuff and make sure that we are not doing some boxed math, which I'm pretty sure we aren't doing. And then I don't think we have any reflection in here, but might as well turn this on too. So this is kind of, if you're trying to write performant Clojure code, oh, not def set, sorry. find it. Okay, let's start a REPL again. If you're going to do any sort of performance critical Clojure stuff, then you really want to turn these two on, because both of those, doing reflection at runtime and doing boxed math, are both just killers for performance. Yeah, so that's our first solution. Yeah, and there we already have some boxed math. Let's TS is a long and bus is a long, then these are all longs, no? Or does that not work in a 4? Does it warn us? Unchecked minus, yeah, the minus. Oh, okay, let's just, yeah, in a let this doesn't work, and so I guess, let's do this. Doesn't like it here either. Okay, let's say TS. No, but that's okay. I mean, it doesn't matter. This one is fine with the boxed math. Parse 2, demo parse 2, real parse 2. Yeah, so our bus cycle, and here we already, so here at least I should be able to just put some of these on here, right? And then same with this one, I guess. Long, yes, okay. That might already make a huge difference. And then, yeah, same thing here, whole bunch of boxed math. So yeah, let's just, all of these are just longs, right? No, BC is a seek, but it's a seek of longs. And even after warm up, still takes like a couple milliseconds. So yeah, clearly there is a better algorithm for solving this, but I don't feel like breaking my brain too much over trying to find that. So let's make this nice and big. Feel like I'd rather try to optimize what I have just a little bit, see how far we get with that, and if that doesn't work, then just gonna call it a day. Which process? Oh, I have 2 AOC processes. That's not cool. Why is that one still lingering? Oh, it's the visual VM itself which started in the same directory. Okay, so I just kind of want to see where it's actually spending its time. I mean, it's probably in those lazy sequences. So let's do that again. Boom, 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 boom. Yes. Parse to, demo parse to, real parse to, bus cycle, narrow cycle down, and then, yeah. Run that. So now it's spinning. Is it? Yes. So we want number 18. Come on. 18. Let's sample that CPU for a bit. And I guess this is the thread where the stuff is happening. Yeah, and so yeah, you see here, filter. So yeah, it's these lazy filters. Oh, actually, transducers might come in handy here, because we got a lot of intermediate sequences now. Again, you know, like, I'm not sure if we're gonna get anywhere with this. We probably need a much smarter algorithm. But if we build up a transducer, so we take off this last argument, or this, in this case, first argument, so that we just get the filter back as a transducer. And then we say apply comp over map narrow cycle x form SS. So we're basically, you know, getting a filter transducer for each subsequent form, combining those all with comp. That's our X form. And then we say take our original cycle and transduce over this X form, and we give it a reducing function because we really just want the first one. Now this, I guess, needs to have all the, what do we transduce? Yeah, we do have an init. Something like that. Just say like terminate when you get there. Does that work? doing something. Let's start again here. Sampler, CPU. Yeah, so now instead of having all these nested filter sequences and building up all these intermediate sequences, we're sort of doing it in a single pass. Is this really going to help much in this case? I am not sure. Yeah, I'm gonna call it there. We went over the hour. Maybe I'll think of a smarter way to do this later. I'm just gonna let this run for a while and see if this terminates. So yeah, thanks for watching. Have a nice Sunday, and I'll hope to see some of you on the stream tomorrow. Ciao.